Hey guys, I'm back for the last part of geometric mean. We are continuing what we did earlier. Okay, so we're not going to really pay attention to the theorems for geometric mean. We're going to focus more on setting up proportions and finding corresponding parts. Okay, so let's take a look at number 8. Okay, on number 8, we're going to look at the information that was given to us. If you take a look at the triangle that I'm highlighting in red, they give us two pieces of information. Okay, they give us the long leg and they give us the short leg. Okay, so if we were to take this triangle and rotate it to where the right angle is on the bottom, the triangle would look something like this. 8 would be on the bottom, X would be on the side. Okay, and if we take a look at the other part of that triangle, the one that I'm doing in purple, we know the short leg is X and the long leg is 12. Okay, so if I were to change that orientation to where it was the same as the red one, it would look something like this, where X is on the bottom and 12 is the long leg. Okay, so let's set up our proportion. X to 8 equals 12 to X. Okay, so we are going to solve this proportion. We're going to cross multiply. So X times X is X squared equals 12 times 8. And you can multiply that out, but I'm just going to kind of leave it as is for now. And then if we want to get X by itself, we take the square root of both sides. And we get X equals the square root of 12 times 8. Okay, so this looks like the geometric mean that we did on the other side. Okay, but I'm going to revamp this. I'm going to break this up using perfect squares. 12 can be factored out into 4 times 3. 4 is a perfect square. And 8 can be factored out into 4 times 2. Okay, so if I take the square root of that, square root of 4 is just 2. The square root of 3, we just leave that as is. The square root of 4 is 2. And then square root of 2, we don't know that. We can't simplify that. So we're going to leave it as is. We're going to take our two numbers and multiply it together. And we get 4. And then we take our two square roots and multiply those together. And you multiply them just like numbers when you have two square roots. So square root of 3 times square root of 2 is square root of 6. And that is your final answer. Okay, let's take a look at number 9. Okay, number 9, we are going to look at the information that they gave us. If I look at the smaller triangle, on the smaller triangle, I see that they gave me the short leg and they gave me the long leg. Okay, so if I change the orientation to where the right angle is on the bottom, 5 is the short leg, X is the long leg. And then on the larger triangle, if we flip that around, X is the short leg, and the long leg, it goes from here to here. They tell us the hypotenuse of the big triangle is 37. Okay, so hypotenuse of this big triangle is 37. Okay, but they also tell us that the base of That little green triangle is 5. So we're going to subtract that to find the long leg on the purple triangle. Okay, so 37 minus 5 gives us 32. Okay, so the long leg is 32. Okay, so let's set up our proportion. We have x to 5 equals 32 to x. Okay, this is a proportion, so we're going to cross multiply. X times x is x squared equals 5 times 32. And then we want to get x by itself, so x equals the square root of 5 times 32. Okay, we can break this down. 32 can be factored out into 16 times 2. I chose these factors because 16 is a perfect square. And it's a factor of 32. And then the 5, I just bring that down. Okay, square root of 5, I don't know. Can't simplify that. Square root of 16 is 4. And then square root of 2 can't be simplified. So we leave it as is. Remember, we can put our two square roots together. Okay, so square root of 5 times square root of 2. That's going to give us the square root of 10. And then we still have our 4 out front. So 4 square roots of 10, that's our final answer. Okay, so we're going to skip around. Let's try another one. Okay, let's take a look at number 11. Number 11 is one of those that kind of trips people out sometimes because one of the sides that we need is going to involve an expression, an algebraic expression. Okay, but let's look at the information that we do have. Okay, so on the mid-sized triangle, we have the short leg and we have the long leg. Okay, so our short leg is 21. Our long leg is 30. Okay, and then we'll look at the smaller triangle. On the smaller triangle, we know the long leg, but we got to find the short leg. Okay, so normally if we were finding length, like pretend x was 40, if we wanted to know the length of the base of that red triangle, we would just do 40 minus 30 and get 10. Okay, but we don't know what x is. So we're just going to call it x, and we're still going to subtract 30. Okay, so we got to set up a proportion. Okay, so we got 21 over 30. That's the short leg over the long leg. And we're going to do the same thing for the other triangle. The short leg is x minus 30. The long leg is 21. And we're going to cross multiply. Okay, so when we cross multiply, we got 21 squared equals 30 times x minus 30. 21 squared, that's 441. And then we're going to distribute. Okay, so we end up with 30x minus 900. We're going to add 900 to both sides. And we get 1341 equals 30x. Okay, so let's go ahead and divide both sides by 30. Okay, so 1341 divided by 30. That gives us x is around 44.7. And there we go. Okay, so we're still just finding corresponding parts and then setting up a proportion to solve. Okay, so let's take a look at some of the ones at the bottom. Let's focus on number 12. Okay, so on number 12, the information that we have, if we look at the large triangle, on the large triangle, we know the long leg. The long leg is x, and our hypotenuse is all the way across. So 24 plus 2, that's 26. And then if we take a look at one of the smaller triangles, we can't look at the small one because all we know about the small one is the short leg, but we don't know anything else. On the mid-sized triangle, I'm covering that in purple. I know this bluish purple. On that one, I know the hypotenuse. The hypotenuse is x. And my long leg is going to be 24. Okay, so we're going to solve this proportion. Cross multiply. We have x squared equals 26 times 24. Square root both sides, we get x equals the square root of 26 times 24. You could multiply that out and then go find the largest square root that fits into that number. But I'm just going to break this down. 26 can be factored as 2 times 13. 24 can be factored as 4 times 6, but 6 can even be broken down. So instead of 6, I'm going to put 2 times 3. Okay, so we're still taking the square root. I have 2 2's. That means one of them can come out. Square root of 13, I don't know, so I'm going to leave that as is. The square root of 4 is 2. And then square root of 3 can't be simplified, so I'm going to leave that as is. So outside the radical, we end up with 2 times 2, which is 4. And then under the radical, we have 13 times 3, which is 39. So our answer is 4 square roots of 39. Okay, and we'll do one last one. Let's take a look at number 14. On number 14, we are finding the values of x, y, and z. Okay, so if we look at the triangle, we want to find the variable that's easiest to solve for. Okay, so if I take a look at the mid-sized triangle, it would be easy for us to find y because this is a right triangle and they give us one of the legs and the hypotenuse. So to solve for y, we're going to use Pythagorean theorem. So y squared plus 24 squared equals 27 squared. (24 times 24), that gives us 576. 27 times 27, that is 729. Okay, so y squared plus 576 equals 729. Okay, Okay, if we do 729 minus 576, we get 153. So y squared equals 153. And then we take the square root of both sides. Once we do that, we get y equals the square root of 153. Okay, so just for reference, the square root of 153 that's about 12.37. You want to be careful with rounding and then having to plug that back into the problem to solve for another variable, because it can make your answer a little bit off. Okay, so we found y. We're going to use that to find x and z. Okay, so instead of y, I'm going to use square root of 153. And we're going to take a look at the small triangle versus the mid-sized triangle. Okay, we're going to do that so we can figure out what z is. Okay, on the small triangle, we know the hypotenuse. The hypotenuse is z. And we also know the long leg. The long leg is square root of 153. Okay, on the mid-sized triangle, we know the hypotenuse. The hypotenuse is 27. And we know the long leg. The long leg is 24. Okay, so we're going to cross multiply. When we cross multiply, we get 24z equals 27 times the square root of 153. And then we're going to divide both sides by 24. Okay, so let's put that in the calculator all at once. Okay, so 27 times the square root of 153. We want to take all of that and divide it by 24. And that gives us around 13.92. Okay, so far we have y is about 12.37. Z is around 13.92. Also, it's okay to leave it exact. Okay, so if you want to leave it exact, it would be square root of 153 or 27 square root of 153 over 24. Those would be your exact answers. Okay, so let's do one more proportion. Let's find x. If you take a look at the large triangle, on the large triangle, x is the hypotenuse, and we also know the long leg. Okay, so let's use that to figure out x. Okay, so the hypotenuse versus the long leg. The hypotenuse on the big triangle is x. The long leg is 27. And if I compare that with the green triangle, the mid-sized triangle, the hypotenuse on the green triangle is 27. And the long leg is 24. Okay, so we're going to solve this proportion. We cross multiply. You get 24x equals 27 times 27, or in other words, 27 squared. So 27 times 27 is 729. So 24x equals 729. And then we divide 729 by 24. You could leave it like that as an exact answer, after you simplify, or you can just write it as a decimal, and as a decimal it's around 30.38. All right, guys, that's it with similarity and right triangles. Hopefully you learned something new today. If you have any questions, you know where to find me. Have a good evening.